Welcome, everyone, and thank you for taking the time out of your day to join us for a webinar focused on advanced early fire detection solutions for the wood product industry. My name is Christopher Winbund with Teledyne FLIR's Sales Enablement Team. Joining me as co-organizer and presenter for this event, Andy Beck from Viper Imaging, our platinum partner in automation. Andy has been the president of Viper Imaging for the past 8 years and has over 25 years in the automation industry. Now, a couple of quick things before we begin the presentation. If you have any questions or comments during the webinar, please use the question pane that can be accessed from the right-hand side of your GoToWebinar console. At the conclusion of the webinar, we should have time to address questions live on the air. In the event that we run short on time, any questions that are not answered will follow up in an email shortly after the conclusion of the event. Now I invite you to sit back, relax, grab a cup of coffee as we are about to get this show on the road. Andy, over to you.
Thank you so much. I appreciate you guys giving us the time and the partnership that we have with FLIR. What we want to do today is kind of go through early fire detection systems and solutions, specifically in the wood products industry. These will expand out into a few different things, but just to kind of go through an agenda of what we're going to talk about. We'll tell you a little bit about who we are as Viper, what are the problems that we solve, and then what exactly is the solution for early fire detection. And we'll do some definitions there on what that looks like. And then get into a little bit of the technical side of it as far as what are the moving pieces, the parts, the components in the system communication architecture. And then we'll spend a little bit of time just briefly going over what other applications there are. There's a world of applications out there for infrared, and I realize within this audience we probably have a wide variety of folks that have been doing infrared for 30, 40 years, and those that have only seen it on a movie or something. So we'll try to address all those and go through everything. So just quickly, and to start at the beginning, who we are as Viper. We're basically a systems integrator / supplier for predominantly FLIR cameras. We're the only platinum partner on the automation side with FLIR. We've had a good partnership with FLIR since the inception of our business, and have partnered with them through a variety of new camera introductions. And the way that we work together really well is FLIR is great with developing the technology, developing the cameras, the cores, and the systems. And what we do is we try to take those cameras and make them usable for automation side of things. So to be able to get the information and the data that these cameras capture and bring it into customers' control systems so that they can make decisions based on that. As a company, we're pretty much in the heavy industry areas. We do a lot in the wood products industry as well as pulp and paper. Those tie in well together. Quite a bit in the steel industry as well as aluminum, some of the other metals. And then oil and gas, and then one of our other large components is all the electrical substations, transmission, distribution, and generation in the electrical substation, or electrical utility world. So that's kind of where we play. That's what we deal with, and as a result, it moves how we do a lot of our systems and how we put a lot of our things together. Meaning, we understand that things are in dirty, nasty environments. There's a lot of areas, specifically within the wood products industry, that can be in some pretty rugged environments. So we try to adapt and plan for those as much as possible. Just a little bit more about what we do, what we believe in as a mission statement. We do want to partner with customers. We see everything that we do as basically the liaison, as I mentioned before, from this wonderful technology that FLIR has to the solution that you need, and bridging that gap in between the two, with the idea of understanding that, we want to be as cost effective as possible. And then the three main things that we're always after is, we're used as safety systems, for instance. So we're always trying to protect, your people, whether it's everything from optical gas imaging, looking for methane gas leaks, to, early fire detection, to make sure that no one gets hurt. Obviously, we want to look out for your equipment, things that can run longer, be more efficient as you go along, that helps, again, your company, which helps the profitability of the bottom line, which drives a lot of that, obviously. So those are the three main tiers of what we build every project out on, every system that we provide. Those are the core tenets of what we do. So, all right, move into a little bit about what is early fire detection, why do you need it, what is the problem? So typically, and you guys have probably seen images like this, in the wood process facilities, they're really susceptible to fire events, mostly because of the material. There's a lot of material, i.e. dust, that rolls in that you have to maintain, you have to go after, but it's inherent in the process. So it's something that you probably can't get rid of, but you're trying to mitigate as much as possible. And even with all those mitigation principles and everything, there's still this large amount of basically stimulant that's sitting there ready to go at any point in time that could catch fire. So what we're trying to do is to get ahead of that, if you will. And we'll talk about that a little more as we go. There's a lot of systems out there. We work with a lot of systems. So again, we're not saying this is the be all end all, but it's certainly a nice adder as well as main point of being able to see if you have something before you get a fire. So there's a lot of really good smoke and spark detectors that work in conjunction with us, but they only see the problem after it's happened, after you've already had a fire. And again, I alluded to this before. Where do these fires come from? Why do you have fires? You've got, in most of these areas, you've got the three main components of starting a fire. You've got a lot of fuel. You typically have an oxygen-rich environment, which is good, and then some ignition source. And we'll talk about those ignition sources, but that's what leads to a lot of the fires that go through. So some specific areas of concern, we want to try to be as non-commercial as possible, but at the same time to focus in on where we're seeing these cameras go in, where they're being used. The planer room, for instance, very fine dust. It's generally closed off, so it's a hazardous area, meaning that you have to protect from any sparks, any type of ignition sources going on in there. But it also makes it a lot harder to get in and maintain the system, to be able to properly lubricate bearings, for instance, and that can lead to dust covering those bearings, those things heating up and catching on fire. And the same goes with dust collectors, cyclones. You see them all listed out there, but a lot of where there's a lot of fine dust, that's a lot harder for you guys to deal with. We realize there's a lot of different ways to do it. But those are going to be areas of concern wherever you're doing cutting or moving around a lot of this material. You'll have this debris build up, and you'll have this basically the source that you're trying to get around. And one of the main areas that we see it on is, yes, there are certain areas where you could have a spark or an ember from a process. If you're looking around kiln dryers or something like that, there's going to be fire, there's going to be flames, and typically most industry applications are aware of that. They're hyper concerned with that. Where we see a lot of the other fires are the places that you typically don't get to. Again, like I mentioned before, if you've got a motor running a conveyor belt that gets covered up in sawdust and the maintenance guy doesn't know it's there, and he's going out to do his lubrication on a periodic basis, he doesn't lube that motor. Well, that bearing heats up over time, and that can be the ignition source that you're looking for. And then the other systems that we see are just bulk storage. You can get into some spontaneous combustion basically by itself with it sitting there. There's some moisture in the fuel itself that can lead to a fire, as well as around chemicals and hydraulic leaks going through that process. So one of the main areas of where these fires are caused is around electrical inspections or around electrical systems, I should say. Anywhere we're going to have any of this, electricity that's flowing through, you don't think of it as being an ignition source a lot of times, unless there's a short somewhere. Well, that's not necessarily the case. Infrared cameras were really designed and built around the electrical industry. when current is flowing through a system, if there's an interruption or something to that, it's always explained to me, it's like water flowing down a stream. If it hits a rock, you see a ripple, and that's the ripple that comes out. The same thing that happens with electrical current as it's flowing through a system. If there is a quote unquote rock, which means like a loose connection or something like that, that shows itself as heat. That's why thermal cameras have been so great in doing all that they do over the years for monitoring and being able to catch these anomalies and problems beforehand. So when you mix these together with combustible dust or specific applications where there may be some hot work going on, if you've got some guys welding or doing something like that in the area, these are certain areas of concern that you need to be looking at all the time for, as well as any equipment and machinery interfaces with each of these. So on the early fire detection, this just kind of goes through the stages of a fire. And what the whole goal is you don't want to have a fire. You want to be able to maintain your process. You want to be able to run through everything with as little downtime or anything being affected by something as bad as a fire, for sure. So you want to be able to monitor that. So you're doing a lot of things, I realize, in the housekeeping side of things, in the process monitoring side of things, to help do that. And you've more than likely got fire systems. You've got spark sensors, smoke detectors in the system to when that fire does develop, you can catch it. So the idea behind using thermal imaging for early fire detection is to try to identify those hot spots before they get into that full growth period, and definitely before they're fully developed. There's once the fire begins in a lot of your applications, it's really hard to contain. It's almost, and in some areas there are explosive areas to where they can be rather dynamic on the growth of what the fire system is going to go through. So that's where we want to catch the thing, is everything down here in this incipient. We want to be able to see it while it's smoldering before it actually grows into a full fire. So how does the system work? We'll give some images here just to see, how do we see anything? How are you looking at it before a fire occurs? Well, typically what's happening is that temperatures are building up. And I used this application before, but again, it's to note that this is one of the better applications, because as you see some of these motors covered in dust, as you see some of these larger rotating equipment covered in dust, that's where you have, again, something that's not being lubricated, which is going to overheat, which is going to cause that dust layer to begin to heat up to try to reach that ignition point. So what we're trying to do is catch that on the front end, to be able to say, hey, this system or this area was at 120 degrees. It has gone from 120 degrees to 140 degrees in 5 minutes. Something's happened. So there's certain things that you want to look for as you go through to see how things are changing, how fast they're changing, how large of an area is changing, and then is it going over a predetermined limit. So that's kind of how the system works, and we'll kind of come back to that overview in a second, but just wanted to kind of dive into what we're using for these type of systems. So a lot of you are probably familiar with FLIR on the handheld side of things. I've been selling handheld cameras since the 60s. And those are great. Those are perfect for being able to walk around and do electrical scans, to do some monitoring of critical areas during critical times. But what we've been pushing towards is a lot more continual and continuous monitoring of these systems. So FLIR has two new series of cameras over the past couple of years that they've released that bring a lot to the table. Again, the base core technology is the same. You've got a detector in both of these cameras. It's actually the same detector that's in both of these series of cameras that basically looks at the field of view, looks at everything that the camera sees, that goes through the lens, and it says how much energy is coming off of that, and it transfers that energy to a number which is the temperature. So these are all calibrated to be able to look at the field of view and say, hey, everything we see in this field of view is going to be at this temperature. Not everything, each individual pixel. So just to kind of give you an overview, because there's a lot of numbers. FLIR throws a lot of numbers at you. We throw a lot of numbers at you. You guys deal with a lot of numbers on a regular basis. But the two main series, this FLIR A50 or 70, and then the FLIR A400, 500, 700, the big numbers, meaning let's just say the 50, the 5, and the 7, for instance, are the resolutions of the camera. So you have a, like an instance of an A400, it's a 320 by 240 detector. So it's still a very good resolution camera, but not super high resolution, meaning that if you're looking at an area that's 60 feet wide, you're only going to be able to resolve down to maybe, and you know, if you're looking at 60 feet wide area, you may be able to resolve down to maybe a couple inches, depending on the lens that you're using, or excuse me, maybe 4 or 5 inches with a 320 by 240. As you step up in those series to the 500 or to the 5 or the 7, that ends up going to a 640 by 480, which is 4 times the resolution. So basically you're putting more pixels on that image and you're taking more measurements and you're getting that spot size down to a smaller spot size. So again, 60 feet, instead of looking at a 4-inch spot, you may be looking at a 1-inch or 2-inch spot. And that'll help you be able to resolve these differences down if you're looking at some fairly small areas. If there's some areas that are going through and if you're concerned about, you know, specifically electrical contacts, for instance, you want to make sure that you have a small enough spot size to be able to monitor that and measure that, because otherwise what it's going to do is it's going to measure everything in and around that 1 pixel, meaning that if you're looking at a connection point and the sky is behind it, the connection point may be 150 degrees, but the sky behind it is minus 40. So you're going to have an average there. So again, it's important to have the right resolution with these cameras. And so with that, that's how you would determine each one. The main difference between these two particular series are the 400, 500, 700 have optics that can be changed out. So you can change from a 12 degree to a 24 to a 45. Yeah, so you can change out those field of views so that you, if it's not the right application, you can change that out. Typically, if we do the legwork correctly on the front end, that's not necessary. The other nice thing about these cameras, though, is that they do have a motorized focus. So if you're putting a camera system on a pan and tilt, for instance, and you're looking at something that's 10 feet away and you're looking at something that's 80 feet away, you're going to need the ability to automatically refocus electronically from a remote area. Those cameras allow you to do that. And then they also have an extremely high temperature range. They can go up to a couple thousand degrees C. So that's when we move into those series. A lot of what we're doing on early fire detection is you want to catch these systems when they're a little lower temperature. So the A50 and 70 series is a nice way to go about that, because they are a lower temperature. They are a fixed focus, meaning you can still focus them, but once you focus it, it's manual and then you kind of forget about it, which is fine for a lot of these applications that are going in there. And then other than that, these systems offer a lot with what they're doing. So for instance, we'll go through and just say, this is another way that FLIR brings you some options as the customer, to where you can say, hey, you know, what all information do I need to get out of it? So they've broken these cameras. Once you pick the resolution and the lens, then you have to decide, do I want a smart camera or do I want a streaming camera? So the smart camera does have more cost for just the hardware side of it, and the streaming is less cost. And so we'll just tell you that if you use the smart, you don't have to use a computer. You can stream, you can talk through, and I'll talk through some of these different features here, right back into your system without having to have a PC, which is very inviting, very nice for a lot of things. There are some things that we do where we integrate these cameras with our Viper Vision software, to where it adds a lot more components and complexity to the system, or not complexity to the system, complexity to the measurement, to actually simplify the system and bring some of that in. So just as a standalone basic system, if you needed to, we call them ROIs, or regions of interest. So within the field of view, if you want to draw a box or a line or a polygon of around a certain thing and say, hey, this is the area that I'm concerned about. I'm not concerned about the rest of the things that are in there, but this is what I want to see and this is what I want to measure. You can definitely do that on the camera, standalone. You go set it up with a laptop, and then you can alarm straight off of that. So these cameras are very unique in that they have a digital output on the back. You can get an email straight from the camera. There's different ways to save the images. There's different means of communications. They have some Modbus communication built in, so you can actually stream some of that data back out. And one of the nice features that they have is all of these systems can integrate with your current VMS system. So if you have a video management system, you can bring the image back into that as well. The data will be sent to your controller by another means, whether it's, again, Modbus or MQTT, something like that. But you're able to see and view those images in your current system, and that you get some duplicity there, which is great. Gives more eyes kind of on what's going on. There's a lot of applications to where customers decided, hey, I need a little more. So for instance, if you've got an area that you're monitoring that is going to have fork truck traffic going through, well, those fork trucks have high exhaust or hot exhausts. So as you look at them, as you're viewing this large area, and say I've drawn a box around this storage area to make sure that there's no fire, you're going to see an alarm anytime that fork truck comes in, because it's going to say, hey, it's in this inside this box and it's over. So we've done a couple things within the software to take advantage and to get away from that. So we have different things like a rate of change. Did something happen quickly, too quickly, or not quickly enough, or there's a certain number of pixels over and under. So we do some things to kind of advance on the alarming. There are some, and I'll show you some images here in a second, of the multiple cameras in that field of view. A big one that we do is trying to minimize the number of cameras that are required to cover an area. So you don't have to have 6 cameras to look at a certain bunker application. Maybe you could do it with 2 cameras that are on pan and tilts, and those pan and tilts actually move the camera around to where you take, quote unquote, a tour. So at each tour stop, it does a different measurement. It can draw regions of interest for each one of those. And there's a lot of other more advanced features on there. There's a web server application. So if you have this, and this all does reside on a on-site PC, to where you would have the software running, but you can have things like a web server. So you could be sitting at your desk viewing that live screen, seeing if there's any alarms or anything going on. And then the amount of outputs that we can do, OPC, whether it's DeviceNet, Profinet, DNP3 is not on here, but that's another one that we do as well, to be able to kind of move through that. So that's kind of the cameras. That's a lot of technical information to say, there are a lot of ways to get the temperature data from your system into your control to be able to make a decision. So it's not somebody sitting there watching the screen all the time, although you can do it as basic as that as well. But a lot of different ways to do that. A couple different options are listed there. So another big thing is, how do you make these cameras live? How do they stay alive in your industry? Again, there's a lot of dust. There can be a lot of traffic. We realize there's a lot of big guys with big wrenches walking around at times. So we've developed some specific enclosures for these type of areas. Heavy duty machined aluminum. They are all IP67 rated. So if you're doing some wash down or something like that, these will definitely hold up to it. And then we do some options for that, as far as everything from a air purge system, to where if you have to put it in a hazardous area, like a planer room, for instance, or things like an air kit, to where it'll have a front window blow off and a vortex cooler. Again, we put these on pan and tilt so that you can do multiple locations just within that, or you can view multiple locations from that one position. So that's an important component of that system, is the camera itself, and then how are you going to protect it, putting it in an enclosure. And then if you go with the option of the streaming camera, we have this software that again I mentioned before. So what you're seeing on the screen here is a 7-camera system, to where we're looking at various areas within the mill. So these are all fixed mount cameras. They're all in there. You can tell where we've actually drawn polygons around it to say, these are the areas of interest. I don't want to see the kiln. I don't want to see the ductwork. I don't want to see these areas that are hot, and they're supposed to be hot. And so you can monitor that. You can put a really almost an unlimited number of these regions of interest in there to get that data back. And that's what you're doing your alarming / monitoring on. And again, this system can be as passive as you want it to be or as active as you want it to be. So if you just want it to gather the data and stream it back to you via OPC, then it'll just stream that data back out, and then you guys can make your decision in your PLC or SCADA system as well, or whatever you need. Or we can set up a lot of those alarms, a lot of that internally, and we can control things like the relay on the back of the camera to turn on a horn, turn on a light. There's a lot of those things that can be done to give a lot of indication of what's going on. And the nice thing is you can do multiple assets at the same time. So you've got this one screen that shows everything on there. And again, this can be redundant. This has all the temperature data and all the control, but it can be redundant with a VMS, a video management system, to be able to put all that together. So it's a nice feature of how it all comes together as far as bringing in everything. And this kind of shows a little bit of that architecture and what some of the options are, to where, we realize that everybody is different in how they want to monitor their means that they monitor. Some guys are full Allen Bradley houses, and they understand that they're only going to do that, and this is the way they're going to do. Other guys are using SCADA systems in there. Other guys are just using a VMS system, for instance, to where they just monitor it, and they're just looking for an alarm and something visibly on the screen for something to look at. So this kind of shows just an overall architecture scheme of everything that would be needed for a system, for instance. So, you can take the camera, as we mentioned in that first little thing, and go with a smart camera and go straight into whatever your application may require, whether it's on a pan and tilt, whether it's on a fixed mount location. This kind of shows some of the stuff and the various options that you can bring out to talk and to work with your system to get that in. And we just listed a few of those systems down there. And that's pretty much how all of these systems go for early fire detection. Again, you're trying to monitor a large area or a small area. So, you would determine the camera, the enclosure, whatever your control communication needs are, which would drive whether you need software or not. And that pulls it all together for that early fire detection to make sure that you're seeing things before they cause ignition. So that one of the other, so there's a lot of applications. We talked about early fire detection here quite a bit, but we've used infrared cameras for a crazy amount of things, from food processing to auto manufacturing. Again, the bread and butter at the beginning of the time for all electrical, or for all systems, was the electrical monitoring system. And that's still a crazy important part of it. I'm talking about electrical switchgear here, to where FLIR has a small camera that you can actually mount inside the switchgear for continuous monitoring of that switchgear. It keeps you from having to open up the switchgear to go through all the OSHA compliance of doing that. But if you need to monitor that, they actually have a small camera that's very low cost to allow you to continuously stream that in there. In lieu of, or in addition to, putting in IR windows, having the guys use the handheld cameras to go out for routine maintenance. So a lot of areas in that electrical world that can use a camera. Another one within your industry are the log pad applications. So, you see this image up here, wherever you're doing a plywood mill and you're pre-soaking a lot of these logs, you can't see on a nice cool day, you physically can't see what's going on in there, and those logs get jumbled up. So what these cameras do, you can use a non-radiometric camera, meaning it doesn't even need temperature measurement, which gets you a little lower cost again. And there are some options through FLIR for that, to be able to effectively, quote unquote, see through that steam, see through that fog, and you still get a clear view, as indicated on there, of where those logs are lining up to make sure they don't get jammed up. That's been a pretty consistent application for us over the years. Done a lot as well on the other side, on the processing side, with like the paper rolls. Whether you're looking at for clog nozzles, overspray, some rub that may be going on, the image is going to be a blur in some respects, but you will see some striping. You'll see some different variations across the width of the roll as it goes through. And again, more in that paper side of things, but the kiln monitoring, to be able to look for refractory degradation, and see if there's any brick fallout in there. Those are some things, and even down into the processing part. We've looked at glue sealant on packaging side to make sure that, hey, the packages of paper, once they went into the package, the glue seal went all the way across. It went in the right place. One of the things that FLIR has done really well and has grown a lot in the past few years is in the optical gas imaging. Anywhere where you have some volatile organic compounds, VOCs, if you have methane, propane, those kind of things, they have cameras that can actually identify and spot leaks in those systems. That's obviously a safety concern. So you want to try to minimize that. And those can be handheld as well as fixed. And then kind of the typical one that, you guys have all seen are, perimeter security. Anywhere you're trying to look in and around your facility, you want to use that same ability to see regardless of the time of day. So nighttime, daytime, fog, rain, you get a lot better vision, a lot better imaging using thermal imaging in that endeavor. So those are some of the other applications that can be used with thermal imaging. There's a lot more. We always encourage folks, if you've got a handheld camera, just turn it on and walk around. We don't get out to whatever you're going to monitor and then turn it on. Turn it on when you're walking around, and obviously stop and do some scanning. But anything where you could see a thermal difference. It's amazing the different things that we find even today that we've never thought of before as applications for these cameras. The cost has come down, the capacity of the cameras has gone up, and it's really a good time for this switch, if you will, from portable routine maintenance only to adding automated fixed mount cameras in over time. So that's a little bit about of the system itself. This is our contact information that's on there. We'd love to talk to you about your application. If there's something that you want to run by, say, hey, this is what I'm thinking. This is exactly what it looks like. We've got some systems out there where we pretty much used to do everything custom, and we still customize a lot of systems. However, what we found is almost all these systems end up using the same thing. So a lot of this we've kind of combined into some different systems. We call it the Predator system, but I'm happy to talk to you about how those can integrate in and help you identify which FLIR camera will be best for your application, and how that could help you on down the road. I appreciate you guys listening, and again, I think we're going to open it up now for some questions.